Lesson 38, activities. So we're going to find this integral on the calculator in two ways. In the demo, we just approximated it. I think we got 14.5. So let's see if we can type this into the calculator. So here we go. On my calculator, this is what it looks like. We're going to go into y1. We're going to type x squared. And then we're going to graph this function. We got to make sure the window includes 0 to 3 because those are the limits of integration for this one. So I'll just do zoom 6, which is the standard window. So there's our parabola. And then we're going to go into calc, which is above trace, a second trace. And then the one that we want is our brand new symbol right here, integral of f of x dx. So hit 7. Then it's asking us for the lower limit. That's this number at the bottom, which is a 0. So we hit 0, enter. And then it wants the upper limit, which is this one. We hit 3, enter. It's going to pause for a moment and then shade in the area and tell us the right answer is 9. Okay, so that is one option for finding this exact area being 9. So our 14.5 was obviously too big by quite a wide margin. This other option you do on the home screen and doesn't rely on seeing the picture. So you go into math and then we scroll down. It's all the way down here, number 9, math, and then 9 for FNINT. I'm going to clear it just so you can see that if you just remember that it's a 9, you don't have to scroll every time. Okay, so depending on your operating system, you either want your calculator to look like this if you have the new OS, or this, which is what I have. So I'm going to type the function, x squared. Then I do comma x, that's the variable, it's almost always x, comma, and then the number at the bottom, comma, the number at the top. Don't need to close the parentheses, but I will. And we hit enter, and of course we get the same answer of 9 that we did using the graph way. Okay, so pause the video here, read 2 and 3. And we're going to work on number 4. So we're going to use technology to find the area, remembering that area is always positive, between the curve f of x equals x cubed, which is pictured there, and the x-axis from x equals -3 to x equals 0. All right, so the first one, x equals -3 looks like it's here. Over to 0 is here, so I want the area between the curve and this axis. Now the curve happens to be below the axis here. I'm going to approximate it going out that way. And so the area that we actually want is the area in between these 3 colorful things that I've drawn. So it's that region in there whose area we want. And so we're going to write an integral before we use our technology. So the integral that we want is the integral of, and we're going to put the function here, x cubed dx. Always put dx at the end of your integral. And then in particular, the limits here are -3 to 0. Typically, you put the smaller number on the bottom. You don't have to, but typically that's what you do. So we're going to type this thing on the calculator using one of the 2 ways we just discussed. I like this way on the home screen, so I will do math 9, x to the 3rd, always comma the variable, which is x, comma -3, comma 0. Now before I hit enter, I'm going to say that if you understood what you read in numbers 2 and 3 above, then you should be expecting a certain kind of number here. You're expecting a negative number here because all of this area is below the x-axis. And so we're not going to get the area, we're going to get the negative of the area. So negative 20.25 is the correct value of this integral. But the answer to this question is positive 20.25 because this question asks for area and the integral will give you the signed area. Okay, there's another option so you don't have to even think about changing it to a positive. We might do that other option here, but this one's easy enough to just do it that way. Okay, so let's take a look at part B, which is looking for the area between -1 and 2. So -1 is here and +2 is here. And so we're going to go up to the curve there, and we're going to go down to the curve there. And we see that we actually have 2 different pieces. There's this one here, and then there is this one here. So we've actually got 2 separate areas here. One of them is above the x-axis, and one of them is below. And so the common wrong answer is to say that what we want is the integral from -1 to 2 of x cubed dx. And I say that's the wrong answer because the calculator assumes that anything below the x-axis corresponds to a negative area. So the calculator is going to calculate the area of this red stuff here, the area of this red stuff here, and it's going to actually take this positive area and subtract the area of this one. And so we're going to get some cancellation. I want the total area. That's not what we're going to get here. So two options. One option is to make it so that the integral doesn't go all the way up to 2, but rather stops when the area goes up to the positives. And so I think that this function x cubed crosses right through the origin. So that's where we're going to stop it. So we're going to do that integral. And then separately, we're going to do the integral from 0 to 2 of x cubed dx. So separating into two different integrals so that we can handle the fact that we want all of these areas to be negative, even though the calculator is going to, we want all these areas to be positive, but the calculator is going to give us a negative answer for that. So here we go. I will do second entry, so it just recopies. And so in this one, I wanted to go -1 to 0. Not surprised to get a negative answer there, so that's this one. And then we'll do second entry again, and this time we'll go 0 to 2. And this one will give us a positive answer, and we're supposed to treat both of these numbers like they are positive to get the total area. So this one turned out to be -0.25. This one was 4. If you add them up, you'll get the wrong answer, which is 3.75. What we want to do is add up their absolute values. Area is positive 0.25 plus the 4, or 4.25. I did say there's a way to do this in a cleaner fashion. I don't expect you'll do this, but if you wish, you can. I'm not going to write it, but I will show it here. So instead of doing it that way, we could do math 9. And really what I'd like to do is have all these things be positive. And the way to take any function and make it positive is to do its absolute value. And so the absolute value is built into the calculator. It's inside of math. And then it's over in numbers. So go 1 to the right, and it's right there. So we want the absolute value function for x to the third. Close the absolute value, comma x, comma, and now we can do the whole thing from -1 to 2. And the calculator here is going to know that everything is positive, so it's going to add positive 0.25 and the positive 4 and give us almost the right answer, 4.25 there. So that's one way to do it. More typical at this point in your calculus lives is to just split where the thing crosses the x-axis. Okay, let's use technology to evaluate this integral from -2 to 2. So here we go. -2 is right here. +2 is right there. Let's get a real good handle on the regions that we're talking about. So it looks like this one, and then it goes over. I am not convinced that this one crosses exactly through the origin. Crosses the x-axis somewhere, but I don't know exactly where. And then this other part looks like it goes up until about there. So it's not the entirety of that bottom hump, the part that's below the x-axis. So let's see what we can do here. So we're going to go to the calculator. What I really need to know is what the value is of this x-intercept, because I need to split and write two integrals, and I got to split it right there at that x-intercept. So we're going to use technology to help us find the x-intercept. So we do second e to the x minus 5x. Standard window is probably okay here. And so you can see here, it definitely doesn't cross through the x-axis. So we're going to do second calc, and we're looking for 0. That's what the calculator calls the x-intercept. So we do number 2. It wants a left bound, so just put the cursor clearly somewhere to the left of the correct answer, which is the x-intercept. Then right bound, I just move the cursor to the right over here. Don't move too far to the right. I don't want this x-intercept. I only want this one. So your left bound and right bound are supposed to trap a single x-intercept. The guess doesn't matter, so we hit enter, and it turns out that x is roughly 0.259. So that is where we split this integral. So we're doing the integral from -2 up to 0.259 of the function. And then separately, we're doing the integral from the same 0.259 and then over to positive 2 of the same function. So two integrals on the calculator. We will make them both positive numbers and then we will add them up. Okay, so again, I like to do my integrals out here. By the way, the calculator knows right now that x is this 0.259, so I'm actually going to store this as a, just so I don't have to retype it a couple of times. Okay, so we'll do math 9. The function is here, second e to the x minus 5x, comma x, comma, so this top one is from -2 up until, and then we just call that a, so comma alpha a. So we're expecting a positive answer for the blue because that's all above the x-axis. I'm going to store this thing too. Let's call that b. And then the other integral is from a up to 2. So let's do that one. Second enter will get us the 2 lines prior. So all we're doing here is changing this. So we're going from a up to 2. So alpha a comma 2. I think that's good. Yeah. All right, so this one should be a negative answer, but we're going to treat it like a positive. So what I want to do, we'll store that one as C, I guess. So currently I've got my two numbers stored as B and C. Let's write them down here, 10.99 and 3.74. So then putting these together in the right way tells me that, oh, as I look at this problem, I realize I'm making it way harder than it needed to be. I thought, again, it was asking us for the total area. That is not at all what it was asking us for. It was just asking us for the integral. So we could use the stuff that we've done here to get the answer to this question. So let's do that. B plus C, including this negative part inside of the number C, is going to give us the right answer. B plus C. So that's the right answer. But far easier to get that right answer is to just do the original integral all the way from -2 to 2. And we didn't even need this A business at all. So just from -2 to 2, it's going to take care of the cancellation with some positive stuff from this 11 and the negative stuff from the -3.7, and we'll get exactly that same 7.25 and change. Sorry about that. Let's hide the evidence here. Don't need any of this. But if the question had said find the area between -2 and 2, then we would have had to do all of the work that I thought we had to do. So 7.25. And the point of this question is to make sure that you see the difference between a question that says find the total area and a question that says find the integral. And it is kind of funny because that's an important difference, and I totally messed it up on interpreting number 5 there. Okay, here we go. Do not use any technology to find the values of these integrals. Instead, draw a picture and think about signed areas. All right, first one. The function in this case is f of x equals 8. That is the constant function, a constant function, up there at 8. And this one is asking for the integral from -3 over to 6. And so hopefully you can see very clearly the very nice shape that this is asking you to find the area of. It's a rectangle. The area of that rectangle is base times height. 9 times 8 is 72. Part B, integral 9 minus 2x from 1 to 4. All right, this one's a little bit trickier, but let's do it. So we are interested in graphing the function f of x equals 9 minus 2x. Now that is like an mx plus b, so that is the equation of a line. But I only want to draw very particular parts of this line. I'm interested in what this line is doing between x equals 1 and x equals 4. So what we're going to do is we're just going to find the function values for those two numbers and just plot 2 points and then connect the dots with a straight line. So if I plug 4 in, I get 9 minus 2 times 4, which is 1. And if I plug 1 in, I get 7. So we'll just plot those points. 4 comma 1 and 1 comma 7. And then connect the dots with a straight line. And so, of course, our 1 is here and our 4 is here, and we're interested in the area of a particular shape. So we go between the curve and the x-axis. So that is the area we're interested in. It's a trapezoid. If you happen to know the area formula for a trapezoid, you use it. A lot of my students like to cut this thing into a right triangle and a rectangle, so I'll do it that way. So the integral from 1 to 4, 9 minus 2x dx is equal to, so the area of the triangle is a half base times height, plus the area of a rectangle, that's a base times height. I don't like the fact that I've got the same b and h for both of these because some of them are different. So I'll call it b1 and h1, b2 and h2. Okay, for the triangle. The base of the triangle is that red line segment. It's 3 long. The height of the triangle, you might be tempted to say, is 7. It is not. It is 6. The height of the triangle is just from here down to here. So you have to subtract off the 1. So the height is 6. Plus, now we're doing the rectangle at the bottom, base times height. The base is from 1 to 4, that's 3, and the height of that rectangle is the 1 that we subtracted off before. So 9 plus 3 is 12. That's the value of that integral. Okay, C. Same integrand, 9 minus 2x is the same from the previous question, but here we're going from 1 to 10. Okay, well, the technique above worked out so well. Let's do the same thing here. All I'm interested in is plotting 2 points. So we're going to again find f of 1, and we're also going to find f of 10. So f of 1 is still 7. F of 10 is negative 11. Do we have that right? 9 minus 2 times 10. Okay, that's good. So let's plot our 2 points. 1, 7. And 10, negative 11. Don't worry about scale. 10, negative 11. And then we'll connect the dots with our straight line. And again, 1 is here and 10 is here. And so be very careful as you shade in the area that you're interested in. So part of the area is this triangle. And part of the area, oops, almost went the wrong side. It's always between the curve and the x-axis. So it's that triangle. There's no space in between here. Okay, so the integral is this combined signed areas of the red and orange triangles. So let's find those areas. Half base times height up here. All right, so the base, I don't know what the base is. I need to know what the point of intersection is right here. I need to know the x-intercept. So that means that I need to know when 9 minus 2x is equal to 0. So that happens at x equals 4.5. Okay, so that means now that I have that, I can tell you the base is 3.5 from 1 to 4.5. So that's 3.5 times, and then the height of this rectangle goes from the x-axis up to 7, so that's just 7. And 3.5 times 3.5 is 12.25. You can type that on the calculator. Okay, and then the other one, the orange, the area here, half base times height. So the base in this case is from 4.5 to 10. That's 5.5. And then the height is from the x-axis down to negative 11, so that's just 11. Can I do this one? I don't know about this. 36, I don't know, is it like 36.25? I don't have a lot of confidence in that one. Should I have subtracted 35.25? I think it's 35, 35.75. Let's try that. Okay, but for sure we're checking this one. Okay, so we're doing 0.5 times 5.5 times 11, 30.25. What in the heck did I do? 5.5? Oh, it's 5.5 times 5.5. What I did was 5.5 times 6.5, which of course was not the right thing to do. But hey, I got the right answer to the wrong question. Okay, so glad we checked that one. So that one is 30.25. But we're looking for the integral here, which means signed areas. So the 12.25 red triangle, that is positive because the red triangle is above the x-axis. But the 30.25 orange triangle we need to treat as a negative because it's below the x-axis. So coming up here, this equals the 12.25 positive plus, and then we're going to put a negative in front of that 30.25. And so the final answer here, 12 minus 30, that's negative 18. Makes sense. There's a lot more space down below. I mean, I didn't draw it to scale, but that 10 goes way down to a negative 11, whereas the 1 only goes up to a 7. And also the base to the right is bigger than the base of the triangle to the left. Okay, so negative 18 is good there. And then D is the most complicated integrand on this page. Integral negative 5 to 5 of the square root of 25 minus x squared dx. And there's a hint here because what we're trying to do is figure out what the graph of the radicand looks like. Y equals square root of 25 minus x squared. So you might not recognize the equation in that form, but if you square both sides, then maybe something will happen. Just trying to get rid of that radical. And if that doesn't look familiar, then maybe add the x squared to both sides. And I'm really hoping that looks familiar and that you recognize that that is the equation of a circle centered at the origin with radius not 25. That 25 is r squared. So the radius of this circle is actually 5. So we'll draw a picture. So I'm not going to draw the whole circle for right now. I'm just going to draw that. I'm going to say this is the graph of y equals square root of 25 minus x squared. And the reason I'm not drawing the bottom of that circle is that the square root, when you take the square root of any number, you always get a positive answer at the end of the day. And so y could never be negative here. If I wanted to see negative outputs, I'd have to put that. And so this actually really is only the top half of the circle. And we are integrating, according to this, from negative 5 to 5. But the radius of this one is 5. So negative 5 to 5 is actually exactly the x-intercepts of that top half of the circle. And so this integral is really just asking us for the area of the top half of the circle. Unfortunately, that's something we know how to do. So this is equal to, so it is pi r squared, but it's only half of the circle, so it's half of pi r squared. The radius in this case is 5. So we get 12.5 pi is the exact answer for that integral. Nothing negative to worry about here, because that picture, the graph is always above the x-axis.